So hello everyone, myself Parkojatide, and in this video we are going to solve a LeetCode question 3432 count partition with even some differences. It is from our latest weekly contest that is conducted by LeetCode. So what is the question? First of all, we need to understand the question properly. You are given an integer array nums of length L. We are given a nums array and its length is said to be L. Okay. A partition. A partition is defined as an index I where I should be between 0 to n minus 1. I is between 0 to n minus 1. So we have been given an array, what we have understood up till now. And the question is saying us that there would be a partition, and where the partition index will be, the partition index will be between 0 to n minus 1. Okay, so suppose we have got 0 1 2 3 index a length of 4. So the partition can be done up till here, right? The partition index can go up till here. Why up till here? Because we know that what is n minus 1? If our length is 4, n minus 1 will be 3. And what is lesser than 3? 2 is the maximum element that is lesser than 3. So our partition index can go up to 2. It makes sense because if we will make a partition like this, then it is not a partition because our array is up till here. So we need to make a partition somewhere between the index somewhere should be between 0. Suppose the I is here, so this will be the partition 0 1 2 3. Suppose the I is here, this will be the partition. Suppose the I is here, this will be the partition. I can't be 3 because then what is the partition then? Then the whole array we are considering, right? So this is the definition of partition. And what they are saying that splitting the array into two non-empty subarrays. Subarray means a contiguous part of an array, right? So what can we see here? That we will be splitting the array into two. Suppose this is my array. We will be splitting the array into two non-empty subarrays. Non-empty subarray means we can't take on one side, we will be considering the whole array, and on the other side there is nothing, right? So that cannot be done. And the indices will be of the left subarray will be 0 to I, and of the right subarray will be I plus 1 to n minus 1, right? So if suppose this is our array 0 1 2 3 4, our right subarray is from 0 to I, means 0 to 1, and our left subarray is I plus 1, that is 2 to 4, both inclusive. So what is the question telling us now? Now return the number of partitions where the difference between the sum of the left and the right subarray is even. So suppose the sum of this one we are considering as left subarray sum, LSS. Okay, I will be using this LSS, and the right subarray sum as RSS, right subarray sum. Okay, so what we need to find that how many number of partitions can we make such that the sum of left subarray and right subarray, the difference is even. So LSS minus RSS, this one should be even, and it is a easy level question, so the constants are pretty much less. N is between 2 to 100 and the numbers can be between 1 to 100, right? So we can think of a brute force solution. So this should be even. Even means Even means we know that LSS minus RSS modulus 2 should be equals to 0. So this is the condition of even. How can we think? How can we approach this question? Let me take an example. Our first example is 10, 10, 3, 7, 6. Okay. So how many ways you can partition them? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The first partition that you can make is this one. This will be my left subarray. This will be my right subarray. 1, 2, 3, 4, 5. The second partition will be this one. Left subarray, right subarray. Third partition will be this one. Left subarray, right subarray. Fourth one will be this one. Left subarray, right subarray. And there will be 4 partitions as well. And here you have to find for each partition what is the left subarray sum and what is the right subarray sum. Get the difference and check that if it is coming to be even or not. How can we do that? For the first time, we can run a loop and we can get the left subarray sum and the right subarray sum and check if the difference is coming to be like even or not. So what can we do? We can do a for loop. Remember, if you will remember that the I is between n minus 1 and 0. So we can run a for loop. I is equals to 0 to n minus 2. Why?
Hello, Moto.
So up till I can go up till n minus 1. Why I am writing here n minus 2? Because I am putting an equal to here. If I will remove this equal to, I can write here n minus 1 and I plus plus. So I will traverse the whole array from this position up till this position. And now what I need to do? Now I need to calculate my left sum and my right sum. Suppose my LSS equals to 0, my RSS equals to 0. And to calculate my left sum as well as my right sum, I need to run another for loop. For j equals to 0 to, it should go up till j should lesser than equals to I, because you know for the first partition it is 0 to I, and for the right partition it is I plus 1 to n minus 1. We already know that. So let's run a loop for a loop and let's calculate LSS, the left subarray sum, and let's run another loop and it should go from I plus 1, right? J should be lesser than n minus 1, lesser than equals to, yeah, lesser than equals to n minus 1, and j plus plus RSS plus equals to a of j. And let me come here. If LSS, is it that difference between the sum of the left subarray and the right subarray is even? Okay. If LSS minus RSS, it is very important to give a bracket here, because if we don't give a bracket here, then the compiler the compiler will first consider this one. If the bracket will be noted, this will be calculated and then it will be subtracted. So you should put a bracket here, and if it is, we will make a count. We will see, will be storing how many number of partitions, valid partitions can we take, that we should be returning. And at last, after this for loop is over, you will be return your C. But let's have a look here. Here you can see in this loop we are actually we are actually traversing the whole array. So my time complexity will be n into, for calculating the left subarray sum as well as the right subarray sum, considering both, we are again traversing the whole array once again. So it will be again n, and it is coming to be a time complexity of n square, and we are not taking any extra space, so our space complexity will be big of 1. So can we optimize it a little bit? But here, as you can see, n is very less, n is 100, so n square will obviously run fine, because our time limit is actually 10 up till, we can do up till 10 to the power 8 operations or 10 to the power 7 to be on a safer side, right? So we have actually calculated, we are we can do one thing here. We, if you can see that here we don't need to calculate the left subarray sum and right subarray sum again and again. For each partition we don't need to calculate the left subarray sum and right subarray sum again and again. Here we can do a little bit of optimization, and if we can do that, it will be of time in big of n it can run. So how we will do that? Let's go on to that, how we can optimize this question a little bit. The space is already optimized, we don't have to think about that. And see, if you will see the example, that is 10, 10, 3, 7 and 6, you can see that for the first time, my left subarray sum is this one and my right subarray sum is this one. Okay, this will be for the first time, but for the next time my left subarray sum is this much and my right subarray sum is this much. Can you see something, that when we are going from this to this, from ith iteration to I plus 1th iteration, you can see that for the left subarray sum the next element gets added, right? The next element will get added, and for the right subarray sum the ith element, which will be the current element, it will get subtracted. See here, we will add the ith element to the left subarray sum and we will subtract 10. For the next iteration, we will add 10 to the left subarray sum and we will subtract it from the right subarray sum. Then we can go on to the next iteration. So by this way, if we will pre-compute our left subarray sum as well as our right subarray sum, and then when we are traversing from for the whole array, first check for the 0th element, calculate the left subarray sum, right subarray sum. For calculating the right subarray sum, you need to go to the whole array, you need to traverse the whole array. First of all, do that and start from I is equals to 1, because you separately check it for this partition. You separately check it for this partition and you start a loop from here only. When you are starting a loop from here, suppose this is my for loop, I is equals to 0, 1, 2, 2, 2, okay, I is equals to 1 to n minus 1 or whatever it is given. And you can do one thing, check if left subarray sum, okay, first we need to left subarray sum plus a of I. If this is my ith element, I am adding it. Like for the previous iteration, my left subarray sum is up till this. but now it will going to up till this, so I'm adding it. And for the previous iteration, my right subarray sum is up till this one, this whole thing, but for now my right subarray sum will be up till this only, so I need to remove this element. Right subarray sum minus equals to a of I, and this, then you can check the condition. And the code you can see in another video that is uploaded in this channel only. Here you can see the code. I will explain it a little bit, and thank you for watching the video. Bye bye.